In this video, we are going to evaluate the integral e power 3x minus 2 times e power x over 4 plus 8 times e power 2x plus e power 4x dx. Before start this, let's observe the denominator. Denominator we have e power 4x plus 8 times e power 2x plus 4. From here, if you take it e power 2x as common, then you are left with e power 2x plus 8. Already we have e power 2x, we take it as common, then plus 4. Here we don't have e power 2x form, that's why we just write e power minus 2x. So the first two terms, if you multiply these two, e power 2x times e power 2x, when bases are same, we can add the powers. So when you are going to get e power 2x plus 2x, will get 4x, same like the first term. So now observe the numerator. Numerator we have e power 3x minus 2 times e power x. Here also, if you try to take it as e power 2x as common, then you are left with here e power 3x. If you e power 2x take it as common, you are left only e power x, isn't it? So just left with only e power x minus 2. Here we have e power x. Here we have only x, but we are taking 2x as common. So when you are going to be equal, if you do minus x, then you are going to get x. That's why here we have to take e power minus x. This is the numerator form and this is the denominator form. So numerator form we got e power 2x, take it as common, so you are left with e power x minus 2 times e power minus x, isn't it? This is our numerator form. Then denominator form, after taking e power 2x as common, so then you are left with e power 2x plus 8 plus 4 e power minus 2x dx. This is, so here we can get cancelled. So you are left only e power x minus 2 e power minus x and these all terms. Now observe, if you substitute u as e power x plus 2 times e power minus x. Let's take this and do the derivative of this. What is the derivative of u? This is in the form of f of x plus or minus g of x form. So whenever you have a terms like this, you can split and do derivative, isn't it? So you have to do derivative individually. Derivative of e power x plus 2 times derivative of e power x minus x. So derivative of e power x, which use only e power x, plus 2 times minus of e power minus x, that means plus times minus, which use minus only. So that means we are going to get e power x minus 2 times e power minus x. You observe that the result is same as our numerator. See here, it is same as our numerator. That means we are in right path. Now if you do square on both sides for the u, then you are going to get, we consider u as e power x plus 2 times e power minus x, isn't it? If you do square on both sides, then you are going to get, it is in the form of a plus b whole square, that is a square plus b square plus 2ab. This one gets cancelled, so we are left only 4. And here we have 4 e power minus 2x. The first term is e power 2x. Do you observe? This is same as our denominator. See here, if this 8 you convert into 4 plus 4, so this 3 terms is same as our u power 2, isn't it? So instead of this, we are going to write u power 2. And for the 4, we can write this as 2 power 2. And this is du, right? So we are converting into in terms of u. That means you have to convert this dx in terms of du. After doing this derivative, you get e power x minus 2 e power x. We are doing with respect to x. So instead of e power x minus 2 e power minus x dx, we can write it as du. Simply you can write it as du. That means integral 1 over u power 2 plus 2 power 2 du. It is in the form of integral 1 over x raised to the power of 2 plus a raised to the power of 2 dx. The formula is 1 over a tan inverse of x over a plus c. If you remember, then you can directly write the formula in. Suppose if you forget this formula, how can you find this? I will show you now. Consider this u as 2 tan theta. Then we are going to get, if you do du, then we are going to get a 2 derivative of tan theta, which is secant square theta d theta, isn't it? So let's substitute here. So what we get after considering u as 2 tan theta, u power 2 is nothing but 2 power 2 tan square theta plus 2 power 2. If 2 power 2 take it as common, so then I will left with tan power theta plus 1. Du is nothing but 2 secant square theta d theta, isn't it? Here 1 plus tan square theta is nothing but secant square theta. So just write, instead of 1 plus tan square theta, you can write secant square theta. Now observe this. Secant square theta gets cancelled. Here 1 2 and here denominator 1 2 gets cancelled. So you are left only integral 1 over 2. You are left only d theta. 1 over 2 is a constant, so just take it as friend. Then integral d theta is nothing but 1 over 2. Integral d theta, the value is theta plus c. We consider u as 2 tan theta, isn't it? Let's take that. We consider u as 2 tan theta. From here, tan theta is equal to u over 2. Then theta equal to tan inverse of u over 2, isn't it? So what we get as a result, we got 1 over 2 theta plus c. 1 over 2, instead of theta, I am going to substitute this tan inverse of u over 2 plus c. This is our result. Starting, we consider u as e power x plus 2 e power minus 2. Instead of u, you can write that. So our result is 1 over 2 tan inverse of e power x. That is our original problem, isn't it? So we have to take the original problem, not the u power 2 plus 2 power 2. We consider here u as 2 tan theta, not this one. We don't remember the tan theta formula, then you have to follow this. Consider u equal tan theta. But our original problem is e power 3x minus 2 e power x. So you have to convert in terms of this. So that's why you take it as e power x plus 2 e power minus x. So that's why I'm going to, instead of u, I'm going to write e power x plus 2 e power minus x over 2 plus c.
Wait a minute!